We're going to look at another aspect of precedence. Recall that we said in Python the operators have rules so that we know which are done first, which are done second, and so on. And the precedence, the order of operations, was that the exponent operator was the highest, and then the multiplication and division operators came next, and finally the addition and subtraction operators were third. And so from low to high, this is the so-called operator precedence table. But one thing that we haven't talked about is what happens when we have more than one operator where the operators are from the same group. So for example, what would happen if we had 2 plus 3 plus 4? And you're going to say, well, it doesn't really matter because we can add 2 plus 3, or we could add 3 plus 4, and the result is going to be the same. But here's the problem. Computers, in particular Python, can't do things without rules and procedures in place so that there is consistency. In other words, even though we as humans look at this and say, well, it doesn't matter if I do 2 plus 3 is 5, plus 4 is 9, or if I say 2 plus 3 plus 4 is 7, 2 plus 7 is 9, I'm going to get the same result. But Python has to do it a particular way every time. And so when there are two operators, like these two addition symbols, that are both from the same precedence level, we have to rely on a way to sort of break the tie. And the way we do that is by another set of rules called the associativity of the operator. The associativity for the addition operator says that the leftmost operator takes precedence over the rightmost. In other words, this addition, 2 plus 3, will be done before this addition, the addition of 4. That means that from a programming point of view, we know that two operators having the same precedence will basically have a left to right evaluation. The same thing would be true if we did multiply. 2 multiplied by 3 multiplied by 9. Multiply, same precedence level, left associated, which means the left operator will take precedence over the right operator. And so the way this would be evaluated would be 6 times 9, which gives me the result 54. 2 times 3 would be done first. 6 multiplied by 9 gives me the answer 54. Now it turns out that the exponent operator is different. The exponent operator actually associates from right to left. So if I say 2 raised to the third power raised to the second power, the way this is going to be evaluated is that the rightmost exponent operator is going to be done first. So 3 raised to the second power is going to be 3 times 3, which is 9. And then 2 raised to the 9th power, which I believe should give us 512. Let's try this out in our active code window. So we'll do 2 raised to the third power raised to the second power. And when we run that, we get 512. Now, what if I had actually wanted this to be 2 raised to the third power and that result raised to the second power? I could do that by putting the parentheses around the 2 raised to the third power. Now, 2 raised to the third power is 8. 8 raised to the second power is 64. And when I run, yes, I do get 64. So we can see that, in fact, the exponent operator is associating from right to left. But all of the other operators, multiplication, division, addition, subtraction, they are going to associate from left to right.